Good morning, all. Do you know who I am? I am Triton, the king of the sea.
And I'm Ariel, his daughter.
So, good morning, all, and welcome to a visual journey through ocean dynamics by PTV ICSE.
Father, I have been exploring the ocean currents lately, but I can't help but to marvel at the complexity. It's as if the ocean has its own language, and I wish to understand its whispers.
Ariel, the currents are the essence of the sea. They are the arteries of the ocean.
But Father, I have noticed that they can be unpredictable, sometimes gentle, sometimes fierce. What guides them?
Ah, my inquisitive daughter. For that, let me take you and our guests to explore the chronicles of the currents. Welcome all.
Good morning. Welcome to the Current Chronicles. Ocean currents are influenced by prevailing winds, temperature, and Coriolis force. At high latitudes, the flow of wind is mostly cyclonic and hence it is affected by the monsoon winds. Due to the Coriolis force, the warm waters from the low latitudes are deflected to the right in the northern hemisphere and to the left in the southern hemisphere. Now let me tell you about the 5 major ocean currents. First, the Gulf Stream. The Gulf Stream is a warm current that originates near the Gulf of Mexico and travels along the eastern coastline of USA and Newfoundland, and then it circulates near Great Britain. The Gulf Stream acts as an important source of renewable power generation. Second, the North Atlantic Drift. The North Atlantic Drift is a warm current that originates near Grand Bank, near Newfoundland, and continues towards Western Europe. It keeps the ports of Europe free from ice even during winters. Third, the Labrador Current. The Labrador Current is a cold North Atlantic Ocean current which flows from the Arctic Ocean, passes near Newfoundland, continuing southwards. The Labrador Current merges with the Gulf Stream, creating heavy fogs. It also transports the icebergs from the glaciers of Greenland.
Kuroshio Current. Kuroshio Current is a strong, warm current in the Western Pacific Ocean. It begins off the east coast of Taiwan and flows in the northeastward direction near Japan, where it merges with the easterly drift of the North Pacific Current or the Black Current. It sustains coral reefs of Japan and has coral reefs of Japan. It also brings large fisheries from the East China Sea. Then is the Oceanic Current. Oceanic Current is a cold subarctic ocean current that originates in the Arctic Ocean and flows via Bering Sea southwards and collides with the Kuroshio Current, forming the North Pacific Current. It also has a great climatic effect on Russia and Japan, and also is the largest fishing grounds in the world.
Good morning, a warm welcome to our stall. Today we will be presenting how the ocean currents affect the trade and the sea routes.
The meeting of warm and cold currents affects trade and sea routes. The meeting of warm and cold currents provides one of the best fishing sites in the world. For example, the confluence of the warm Gulf Stream current and the cold Labrador current. The fish feed on planktons. The ocean currents move the organic material off coast, which is the food to the planktons. Thus, more the planktons, higher is the concentration of fish.
Sea vessels move easily along the flow and with difficulty against the flow in terms of fuel and time. Thus, understanding the current pattern helps the sailors.
Warm currents such as the North Atlantic Drift help to save the port along west of Europe from freezing. Thus, it helps in natural maintenance of the ports.
Foggy conditions are created due to the confluence of the warm and the cold ocean currents, which affects the navigation.
Moving of icebergs due to ocean currents may lead to fatal accidents. For example, the Titanic collided with an iceberg, which led to loss of lives. But nowadays, with inventions such as radar system and satellites, such collisions can be avoided. Thank you.
Good morning, everyone. Today, me and my schoolmates are going to be talking about the Coriolis effect. Have you ever wondered why an airplane doesn't travel in a straight line to reach its destination? Well, let me tell you, this is because of the Coriolis effect. This phenomena causes fluids like air and water to curve as they travel above or across the Earth's surface. This impact is the most significant with high speeds and long distances. As our Earth spins around its axis from west to east, there's a faster spin near the equator compared to the poles. Now let's see an experiment here.
Have you ever seen a merry-go-round? Imagine you and your friend sitting in a merry-go-round pass a ball to each other while it is not rotating. It will move in a straight line. But if the ball is passed while the merry-go-round is rotating, it will move in a curved line. You can see this with an experiment here. Imagine this is a merry-go-round, this is you and this is your friend, and you pass the ball to your friend while the merry-go-round is not rotating, it will move in a straight line. But if the ball is passed while the merry-go-round is rotating, it will move in a curved line like this. This is because of the Coriolis effect. The Coriolis effect affects different things in the northern hemisphere and the southern hemisphere. In the northern hemisphere, the Coriolis effect pushes things towards the right and the southern hemisphere to the left.
This is a model of our planet Earth. We have depicted different wind directions, starting with the polar easterlies, the westerlies, which mainly affect India and bring monsoon to India, and the trade winds. These winds affect both the northern and southern hemisphere and are very crucial in understanding the Coriolis force.
Now let's see a very interesting experiment here.
To show the effect of Coriolis on water bodies, we have built a small working model here. This model shows us how a hurricane is formed. The high pressure air surrounding the center or the low pressure area is constantly rushing towards the middle. In the northern hemisphere, the winds get tugged to the right, that is anti-clockwise, and in the southern hemisphere, they get tugged to the left, that is clockwise. Thank you for listening. Ask questions if you have any.
Good morning. Today we will be explaining about gyres. An ocean gyre is a collection of currents formed by wind patterns and Earth's rotation. Gyres help drive the ocean conveyor belt, which moves water around the whole planet and helps control several different factors of ocean health like temperature, salinity, nutrient flow, etc. So as the ocean moves, so does the plastic, which makes it extremely difficult to clean up.
The North Pacific Gyre, more popularly known as the garbage patch, sits above Hawaii, and when the trade winds roll into the islands, so does the marine debris. Ocean gyres circle large areas of stationary and calm water. The debris drifts into these areas, and due to the region's lack of movement, it can accumulate for years. These regions are known as garbage patches. The Indian Ocean, the Atlantic Ocean, and the North Pacific Ocean all have significant garbage patches.
So in order to prevent this vast accumulation of garbage, we can simply refuse plastic and use cloth product or bags for our daily use instead. Here, you can have a look at a chart which shows how long it takes for different items to completely decompose. Thank you.
Good morning. This is a convection box to demonstrate the ENSO or El Niño Southern Oscillation phenomena caused due to rapid increase in temperature over the east central equatorial Pacific Ocean.
As you can see, there are two outlets provided. On one side is a burning incense coal. The air is rising because warm air rises as density decreases, creating a low pressure or partial vacuum.
This explains the normal year, where the Australian continent gets heated up and trade winds from the South American continent blow towards Australia, bringing rain to the South Asian continent.
Now, when I place a burning candle inside, the air on this side is warmer compared to the air on this side. It is created because of the burning incense coal. As a result of this, there is a relatively high pressure area created on this side and a relatively low pressure area created on this side. The lighter air gushes towards the relatively lower pressure area. This is how the convectional air currents are created.
This explains the El Niño year, during which The waters near the South American continent heat up and the trade winds either reverse or get completely lost.
El Nino and La Nina are the opposite states of ENSO. El Nino, Southern Oscillation Phenomenon, wherein the reversal of wind movements occur, causing change in weather phenomenon all over the world.
Thank you.
Good morning, everyone. Welcome to the Whispers of Deep Ocean. Deep ocean currents do produce sounds, often referred to as underwater or oceanic sounds. These sounds are a result of various natural phenomena, and while they may not be able to hear without specialized equipment, they play a crucial role in understanding the dynamics of the underwater world. I am going to take you through the deep waters and make you experience the sounds never imagined to have heard.
So, I'm going to talk about the bloop sound. The bloop sound is one of the loudest sound ever recorded in Earth's oceans. It was first captured by deep sea microphones in 1997. It is a result of some sort of iceberg calving. It was first recorded on the southern coast of South America and was audible 5,000 kilometers away. No more bloops have been recorded after 1997, but such unexplained sounds have been heard. Now let's dive into the world of oceanic harmony and listen to the bloop sound.
Now I'm going to talk about whale vocalizations. Whales, particularly baleen whales, are known for their distinctive vocalizations. These sounds can travel long distances underwater and may be influenced by the surrounding ocean currents. Now let's dive into the harmony of the marine organisms. These sounds include the pops, clicks and whistles of marine life going about their daily routines. Thank you.
Thank you.